This bipolar junction transistor, in test 1 we will cover in question 2. We'll carry 20% out of 50 for test 1. Normally 10% DC analysis and another 10% for AC analysis. Saya belum siap lagi buat soalan. But then biasanya lebih kurang macam tu lah. Okay, so you need to, if you target nak pass cemerlang for the test 1, so you need to buat dua-dua part lah, sebab 10% dengan 10% kan. Kalau satu you memang tinggal terus, let's say tinggal terus on the AC analysis, dah hilang 10 markah kat situ kan. Okay, and sebenarnya untuk this chapter nak kata susah, dia susah sikit. First you nak capture. Kalau you dah faham, dia pusing-pusing pun benda yang lebih kurang je. Okay. Alright, so this is on the chapter objective. Basic construction. Kenapa Hamzah?
Dia kata bau durian.
Dah habis dah musim durian. Okay. This is on basic construction and operations of the BJT. And then this is on biasing. Dia sebenarnya enhancement from the PN junctions, from the semiconductor diode. Okay, for this BJT. Dia ada juga saturations and cut off conditions. This is on the characteristic of NPN and PNP. We will discuss on this. And yang ini is in number 5 is in chapter 3B, DC analysis. Lepas tu kita akan pergi to AC analysis and also okay, finally on AC analysis. Okay, meaning that you kena, first thing is kita kena faham lah what is the bipolar junction transistor. Kita kena kenal dulu the BJT, barulah kita boleh buat the analysis kan. Okay, I want to show on this. Kejap this is, okay ni sekejap lagi. Okay, BJT ni is actually, kalau if we, okay, this is the BJT. It is a very small component sebenarnya. Okay, this is this one. Pernah tengok tak benda ni? Kat mana tengok? Dalam TV. Okay, sebenarnya BJT yang atas tu, yang kiri, yang kiri, this one is BJT yang bulat tu. That one is BJT. Yang leper ni dia dah macam adudu dah. Petak kan. Okay, this one is the FET. Okay, so dia ada 3 pins, 3 kaki, 3 terminal for this one. This is actually the evolved technology tu from this one. Yang tadi tu benda ni lah, ni kan. Yang ni. So yang bulat tu is yang ni tadi. Yang adudu tu ni. Okay. And from history, this one is dulu-dulu punya TV macam mana? Masa you kecil, dia macam bulky kan, dia panjang ke belakang. Same goes with the computers kan. Dia tak ada yang nipis punya, dia mesti besar. And macam ni lah this one. Ini adalah TV zaman dulu. Okay, why it is designed like that? Because in the circuit belakang dia ni, dia ada this vacuum tube devices. Yang vacuum tube ni yang akan transmit the signal supaya dia boleh display on the screen. Okay, ni sambung dengan plug kat sini. So tu yang dia akan ada circuit dekat belakang the TV. That is why TV and the computer zaman dulu dia bulky dan macam kotak. Okay, because the technology dipakai vacuum tube devices. And then from that, ni datang from Europe lah, dari yang putih. Dia guna vacuum tube. Okay, and then around 1980s dia jumpa on the germanium transistor. That is the first one. Okay, germanium transistor. Masa ni the transistor dia tak adalah as tiny as we have these days. Dulu punya transistor besar. Okay, sebab tu komputer zaman dulu pun besar. And then from time to time dia jumpa first dia jumpa yang silicon, and then dia develop mula-mula the germanium, and then develop on the silicon, because on the resources silicon is more reliable, more stable. Okay, and to integrate lagi stable dan signal dia lagi accurate lah as compared to the germanium. And then dalam 1960s diorang dah integrate, they have on the IC. IC is the one yang kalau you tengok yang macam ni ada banyak kaki kiri kanan tu, and then black color, that one is on the integrated circuit. And normally dekat dalam IC tu dia dah ada the transistor. Okay, and itu datang from the IC circuit. So around dalam, diorang dah start dalam 1960s, but then on the smart devices around dalam 2000 plus lah kan. Dalam tahun 2000 lebih tu baru ada yang handphone yang ada screen color. Same goes with the computers and laptop, dia dah ada yang very flat and thin. Sekarang ni punya tablet dah memang nipis lah. Kalau laptop pun dah ada yang very nipis kan. Okay, because that one is comes from this technology lah. Okay, the evolvement, dia evolusi from the vacuum tube, dia nak pergi ke transistor. Okay, and the transistor dia embed into the IC lah. So on the electronic part dia jadi makin tiny. That is why dia punya circuit sekarang ni kecil je. All the components dia dah embed together dekat dalam the circuit. Okay, alright, so this is on the history lah. Kenapa zaman dulu punya TV besar and nowadays punya screen makin nipis. Okay, and this is actually comes from the components of transistor lah. Transistor. Okay, BJT is a type of transistor used in electronic circuit. Apply for applications is amplifications, switching, and also for the signal processing. Okay, transmitter and receiver. Okay, we have two types. Same goes with the diode. For diode kita ada dua region kan, P and N for the diode. Okay, the symbol for the diode. But then for the transistor, it's like kita tambah another one dekat belakang, PNP or NPN. So ini consider like kalau you baca the construction, they call it as that waffle ataupun sandwich. Sebab dia letak two things dekat luar, satu dekat tengah. Okay, ada dua roti, satu burger kat tengah, terus lapar. Okay, so it's like waffle or sandwich. Orang putih dia selalu suka sebut benda tu, sebab tu makanan dia kot. Alright, so dia ada two types juga, NPN and PNP. So like I have mentioned before this, what is the difference between PNP and NPN? It is the purpose is mainly kita guna dalam amplifier ataupun switching. So kalau switching, let's say for PNP dia ini adalah, for NPN dia terbalik. For NPN, okay, 0 is for off, 1 is for on. If for NPN, okay, kalau kita nak off, kita bagi 0, so dia akan off lah. When off, it is open circuit kan. Okay, but then for PNP dia terbalik. Bila kita nak off, kita kena bagi 1, and bila nak on, dia kena bagi 0. So that is where the conditions where they need in such of the possibilities. Contohnya kalau kat depan switch dah tutup, kita tekan, kat belakang dia mesti kena kod terbalik. Okay, itu adalah some sort of purpose lah biasanya. Okay, dia ada lagi banyak applications lah for these types of conditions. Okay, itu adalah beza dia. Lain daripada tu, dia punya operations ataupun dia punya current flow sama je, tapi kaki dia lain lah based on the connections dia. Okay, so itu adalah on the two types of the BJT that we have, NPN and PNP. Okay, for remember yang kita belajar, when we have the extrinsic, so kita ada dopan that we add into the intrinsic. Same goes for this transistor. For P-type, ini adalah the contoh of compound that we can masukkan into the intrinsic yang pure, original one. Okay, we can, kalau nak dapatkan P-type, kita boleh tambah with boron or gallium. Kalau nak dapatkan the N-type, we can use the phosphorus or the arsenic. Okay, this is on 2 types of the compound. Okay, and what else? For a transistor can amplify power, current or voltage. Okay, P, I or the voltage, and also can use for switch, signal on and off. Okay, same goes with the diode. Dia juga ada germanium and silicon, but then sama juga silicon is widely used. Normally memang guna silicon, agak jarang. Kalau in the applications, dia bagi tahu on the applications guna germanium dan guna germanium punya value. Tapi saya rasa setakat yang saya jumpa calculations mesti pakai 0.7 lah. Okay, nanti kita akan tengok kat mana the value of the 0.7, what is the 0.7 value. Okay, and for the transistor, kita ada power, current and voltage. For this transistor BJT, it is actually current control voltage devices. Nanti kita tengok why, because the value of the current will determine the output voltage, the voltage at the output. That is why kita panggil current control voltage device. Okay, for BJT. Maksudnya when we do the DC analysis, yang penting is mesti dapatkan the value of current. Okay, nanti kita tengok current dekat mana. And this is symbol for the BJT. Dia ada 2, PNP and NPN. So dia ada 3 pins. Beza dia, if here, yang ni adalah PNP. So ini bezanya. Okay, apa beza? Arrow dia. Okay, for PNP, dia dekat step terminal tu dia mesti ada V dan juga I. Ada voltage, ada current. Okay, for I, ini IE. Sebab masuk, so dia akan naik lah. Okay, IB, yang masuk mesti sama dengan yang keluar. So this is IC. So because of the masuk sama dengan keluar, that one is Kirchhoff current law. Okay, so IE equals to B plus IC. Okay, that one is for PNP. Kalau for NPN, IE, sebabkan ini tu keluar, yang ini akan masuk. So IB plus IC equals to, sama tak dengan yang atas tadi? This one sama kan? It just direction dia je terbalik kan? Okay, alright, so that is 2 types of PNP and NPN. Samalah, sebab tu bila kita buat the voltage and current calculations, dia sama je. It just directions dia yang terbalik, polarity dia yang kita pusing. Okay, and this is the terminal yang ada kaki pin dia, emitter, base and collector. And always remember that yang ada anak panah is the emitter. First thing to determine kaki dia yang mana adalah tengok yang ada anak panah tu. So emitter. Lepas tu bertentangan dengan dia, opposite of that is the collector. So kalau bawah is emitter, yang atas is the collector. Yang ni, so this one. Okay, why? Because we want to determine which one is connected to the input, which one connected to the output. Okay, and yang tengah-tengah will be the base. Okay, yang tengah-tengah tu. Okay, what else? Tadi I mention this one is for BJT. Selain daripada BJT, another types of transistor is FET, field effect transistor. Okay, field effect transistor simbol dia adalah Okay, kalau dia ada dua jenis juga. This one is NPN, FET, Field Effect Transistor. This one is NPN. Kalau dia punya PNP dia akan terbalik, arrow dia akan keluar. Okay, this one is NPN, this will be PNP. Okay, that is for FET. Another one is MOSFET. Okay, this is MOSFET, Metal Oxide Field Effect Transistor. Selain daripada tu, there is also METFET, Metal Depletion Enhancement MOSFET. Okay, so dia ada banyak jenis. Itu baru 4. Dia ada lagi E-MOSFET, D-MOSFET, Enhancement dan Depletions. But then for our syllabus, kita cuma belajar under BJT sahaja. BJT ni adik yang paling bongsu, yang paling simple. Okay, tapi dia ada banyak lah, because sekarang ni kan in terms of semiconductor transistor punya field, dia tengah berkembang maju. Okay, so dia punya transistor punya jenis ni memang banyak lah. Sebab tu dia ada sampai E-MOSFET, D-MOSFET, Enhancement, Depletions. And then this one, all this transistor dia pakai dalam amplifier. So amplifier pun banyak yang pakai sekarang ni kan. Okay, nanti kita tengok. Alright, so this one, ini apa? Yang ni. Okay, yang ini is the ratio of this layer yang kita ada. Kan kita ada E, base, C. Okay, so all the time, sepanjang masa, the base is the thinnest one, yang paling nipis. Okay, dekat base. Tak kira lah for the PNP or the NPN, dia mesti yang paling nipis. And then dekat setiap terminal, dia mesti ada voltage and also the current as well. Dia mesti ada voltage dengan current. Sorry, this one VB lah. Okay, so kalau IB is the thinnest, paling nipis, meaning that one IB is the, ini keluar sebab IE akan masuk, so IB akan keluar. Okay, so IB is approximate to 0 ataupun very small value, microampere ataupun nanoampere. Normally micro lah is the smallest value. Kalau you kira buat DC analysis, tiba-tiba value dia dapat 20 ampere, so mesti salah, something is wrong in the calculation. Okay, mesti microampere. Ataupun kalau mili pun value yang agak kecil lah. For the IE, normally IE is the largest value, tapi IE dengan IC, IE dekat sini, IC dekat sini, IC keluar. Okay, IE and IC, the value is lebih kurang lah, hampir sama. Kenapa? Sebab IE sama dengan IB tambah IC kan. So kalau this one too small, almost 0, sebab tu IC is approximate to IE. And there is relationship, kat mana saya nak tulis the relationship. Okay, nantilah sekejap lagi kita tengok balik on the relationship. Because of this one, sebab kita boleh katakan IB in some situations dia boleh approximate to 0. So kita boleh katakan IE IC. Okay, kalau dah dapat value IC because of this, so you boleh assume. Tapi bukan in all situations. Kadang-kadang dalam soalan dia dah kata assume IB is too small, so just ignore. So you boleh guna this assumption lah. Okay, sebab tu nama dia assumption, kita assume. Okay, what else? PNP, NPN. Okay, for this transistor also, yang tadi kita tengok dalam TV tu, dalam TV pula, this one, Okay, these vacuum tubes, it is bulky, fragile and consume a lot of power. Kalau yang TV besar tu, dia cepat panas sebabnya dia power consumption is very high. Okay, and compared to this small transistor, this one is revolutions for the semiconductor for smaller, more reliable and energy efficient electronic devices. Okay, sebab tu dia lagi smart, lagi cepat nak proses in compare to, katakanlah you compare komputer yang zaman dulu jenis macam ni with the komputer zaman sekarang kan. Okay, dia lagi fast processing lah. Betul. Okay, apa lagi? Today's punya class memang kita akan explain gini je, tak banyak kira. Okay, this one. Nak tengok on the ratio. Ini from this value dalam kotak ni, dia lebih kurang base is 1 to 150 kan? Kalau base 1, E ataupun C 150. Maksudnya base ni is very lightly doped. Sebab dia sangat nipis, sebab tu value current dia pun very small. Okay, and base is lightly doped. For emitter is highly doped ataupun heavily doped. Okay, and collector is moderately doped. That is characteristic of the base region, emitter region and collector region. Okay, this one same goes with the semiconductor diode. The operation sama je, because we have two depletion region. Satu dekat sini, one is this side and another one is side sini kan. Okay, 1, 2. Because of the concentration gradient, we have majority carrier. Satu majority dia adalah in P, majority is holes. In N, majority is electrons. Okay, so we have the majority and majority carrier. What we have learned in previous chapter 2, because of that we will have diffusions and drift. Diffusion and drift current. Okay, diffusion and drift current. Okay, tetapi when we apply external electric field, yang diffusions and drift current become insignificant sebab value dia too small. Okay, so because of that we will have forward and reverse bias due to this polarity of the external voltage field kan. Okay, tapi sebenarnya inside of that, ini adalah forward bias, this one is reverse bias. How to determine? Tengok dia punya depletion region dia kan. Okay, for forward bias is almost there is no depletion region, tak ada perbezaan kat tengah tu. For the reverse bias, dia ada region yang wider dekat tengah. Okay, and then most of that the effect from the external electric field yang kita apply. Okay, so ini adalah IE masuk, IC keluar, IB akan keluar juga. This one is for PNP. Kalau NPN dia akan terbalik lah. Ada tak? This one is, okay, this is on the current. IE masuk, keluar IC and IB. This one. Okay. And this is the leakage current is considered as the diffusions and drift current lah. This one due to the majority and minority carrier kan, for that too. Sebab dia ada perbezaan positif and negatif tu kan. Okay, so that one is considered as the leakage current, but then because of the value is too small, so kita tak kira in the calculations. Mungkin value dia dalam nano ampere, pico ampere. So bila kita tambah value yang milli ampere dengan pico, ada efek tak? Kan? So kita tak kira in calculations lah. Tapi by theory benda tu wujud. Wujud. Benda tu ada, tapi dalam kira-kira kita tak masukkan. Okay. And this one macam yang saya bagi tahu tadi, IB is very small, normally dalam micro ampere. Tapi kita tak adalah kita terus assume as 0. Sometimes kita tak kena kira juga. Okay. And IE because of this one is too small, we can say that IE is approximate to IB. So, another one is IC equals to beta IB. IE equals to beta plus 1 IB. This is the expressions. This one will not be given. You kena ingat lah. Selain daripada this one. Ini 1, 2, 3. IE. Normally kalau DC analysis kita tulis huruf besar. Kalau AC baru kita tulis huruf kecil Okay, so what else? Okay, so this is under some introductions lagi. BJT has 3 terminals connected to input and output. So dia ada 3 kaki. Contohnya not this one. Okay, katakanlah for this one we connect to V in. So it is either kat sini V out ataupun dekat E, ataupun dekat sini. Tapi V out kena ada satu je. Salah satulah antara dekat C ataupun dekat E. That is why kita kena determine which one will connect to input, which one dekat output. So this one kita panggil 2 port network. Satu dekat input, another dekat side sana output. Kenapa kita nak tahu the 2 port network? Because dekat awal-awal tadi kan ada 3. Okay, this one. 3 ni. 3 benda yang kita akan buat analisis. Okay. We have the power P, current I, voltage V. So for this transistor normally kita apply dalam amplifier. Maksudnya kita nak amplify. Bila kita nak amplify, there must be gain. Bila ada gain, dia mesti ada ratio in between input and output. Okay. So kat mana tadi? Okay, here. Okay, sebab tu penting we need to determine which one is input, which one is the output. Okay, so it is 2 port network. One of the 3 transistor terminal must share the both for input and output. Satu connect to the input, satu to the output, and another one is the common. Okay, depends on the connection dia. Nanti kita tengok few connections yang ada. Okay, this is on the configurations, connections lah. Configurations and connections. All these configurations, connection dia tu, susunan dia mesti ada purpose. Jenis circuit ni untuk apa? So sebab tu dia jadi common emitter. Okay, and another one is common base, another one is common collector. Normally kalau kita ada common base configuration, it has voltage gain but no current gain. Voltage gain apa tadi? AV. Voltage gain AV, current gain I. Okay, AV equals to V out over V in. Voltage at the output ratio to the voltage at the input. Baru kita boleh dapat the gain. Kalau AI, I out over I in. Okay. So for common base, voltage gain dia ada value, meaning that they can amplify ataupun dia boleh makin kecil. But then there is no current gain. When there is no current gain, dia bukan 0, but then it is equals to 1 ataupun unity. Maksudnya dia tak ada factor pula. Dia tak makin kecil, dia tak makin besar. So sama je. Sebab tu dia tak ada gain. Dia bukan 0 because kalau dia 0, if you want to get AI 0, maksudnya it is either I out ataupun I in yang 0 kan. So dia tak boleh 0. Meaning that AI kalau no current gain, it is unity value. So kalau current input 5, current keluar pun 5. So dia tak ada amplifications, faktor makin besar ataupun faktor makin kecil, dia tak ada. Dia boleh juga jadi de-amplifications. Contohnya masuk 5, dia keluar 1. So dia ada faktor dia, ada ratio, tapi ratio dia makin kecil, kan? Okay, itu masuk when there is no current gain ataupun no voltage gain. Dia ada juga no voltage gain. That one is for common base. So for common base dia ada voltage gain but then no current gain. For common emitter, it has both current and voltage gain. Voltage dia makin besar, current pun makin besar at the output. Okay. And we have power. Tadi kan lagi satu. AP. AP ni power gain. Power gain, apa formula for power? P equals to IV. So from there kita boleh dapat gain for the voltage darab dengan gain for the current. So AP equals to AV darab AI. Okay, so if we want to get gain for power yang besar, which one you nak pakai? Common emitter. Because common emitter dia ada current gain dia besar, voltage gain dia besar. For common collector, dia ada current gain tapi voltage gain dia pula yang equals to 1. Okay, but then all these three configurations, all these three connections, dia mesti ada purpose. Dia nak, yang ni nak guna dekat mana? Dia nak amplify untuk current sahaja, dan yang ni nak amplify untuk voltage sahaja. Tetapi normally paling banyak guna adalah kita nak amplify for both. Sama juga sebab kita nak besarkan dia punya power sekali. So common emitter yang paling selalu digunalah. Okay. Okay, this is connection dia. Common base. For common base, which one is emitter? Tengok yang ni dulu. Emitter yang mana? Emitter connect dekat C1 ke C2 ke C3? Emitter dekat sini. First thing is you determine kat mana ada anak panah dia. Okay, so opposite to C1, opposite to E is the C. So yang lagi satu must be base. Okay, so this one base connect to ground. Normally dekat dalam DC analysis ataupun AC analysis, C is considered as short circuit. So ini dia macam pergi ke ground lah. So base kira macam direct to the ground. Sebab tu dia common base. And also base is connect for both input and output. Okay, so common base. This one is common collector. This is E, C and B. Okay, for common collector, this one for AC analysis, this one we consider connect to ground. So it's like yang ini pula pergi ke ground kan. Okay, and this one is common emitter. Beza dia adalah common collector, V out dia duduk dekat E. For this one, V out dia duduk dekat sini atas. Okay, so E yang common for both input, ini adalah input, this is output. So this is base. Kalau ni input, this one is output. Emitter connect to the output, so C yang akan common untuk dua-dua. Okay, first determine which one is emitter, and then tengok input dia dekat mana. So yang lagi satu will be the output, and then yang tengah akan jadi common. Okay, senang je kan to determine. It is important you need to determine, sebab dekat setiap kaki dia ni kita akan ada voltage and current. So tu yang penting kena tahu which one ada. Contoh kita tengok yang ni So ini E, so we will have I, E. So we ada VC, VE. Kat atas ada IC, VC. This one IB, VB. Okay, and in between step 1 ni ada voltage dia juga. Pernah dengar VBE equals to 0.7. 0.7 pernah dengar? Kan? Okay, so VBE in between base and emitter. Itu VBE. Kalau VEB, value dia berapa? Minus. Dia sama je value dia. Because VBE is voltage potential between base and emitter. VEB voltage potential between emitter to base. Point yang sama tapi kita tukar tukar polarity dia je. Value dia mesti sama. Okay. For VCE, dekat sini, from C to E, VEC terbalik lah, minus VCE. Okay. And in between base to collector, we have VCB ataupun VBC. Kan, dia sama je. Ataupun terbalik, sini negatif, sini positif and negatif. So, ini adalah current control voltage devices, meaning that first thing is important untuk cari IC, IE and IB. From there, you can get the value of VE, VC, VB. Same goes with VCE, VCB. Yang ni tak perlu kira, all the times will be 0.7. VBE. This value will not be given dekat dalam calculations. You need to know. Tak perlulah hafal, just 0.7 sepanjang masa. Okay, this value dia macam common je. Benda yang macam it's like common sense. Macam tu. Ya. Output input. Okay. Normally VS ataupun VI is the input. And V out tu biasanya dia akan tulis lah, ataupun V2. So first determine anak panah dia dekat mana. Lepas tu you tengok voltage source connect dekat pin mana. And then output connect to which pin. From there kita dah tahu dah kaki dia C, B and E. And then dekat setiap kaki dia mesti ada current and voltage. Okay. Lepas tu nak pergi lagi detail, dekat setiap kaki dia mesti ada voltage potential. Ini lagi detail lah. All these thing is the parameters that we will calculate in DC analysis. DC analysis meaning that kita akan buat KVL. Dekat dalam this circuit kita akan buat KVL. Okay, kita pergi circuit ni lah. Circuit tu bawah dah penuh sangat. Okay, in this circuit kita akan buat KVL. Contohnya, current masuk, dia akan lalu sini, turun bawah. Satu laluan. Another pergi sini, 2. Another one, 3. Okay, so kita akan buat KVL untuk cari value current, voltage. 2 je, tapi dekat setiap kaki ada IB, IC, IE, VCB, VE, VB, VC. And then macam mana nak dapatkan lagi all that things is relationship yang tadi ni lah. This one. Satu yang ini, 2 and number 3. First thing kena buat KVL dululah dekat step 1 tu. Nanti dalam chapter 3B kita akan buat KVL dia. Just sekarang ni just nak bagi you guys nampak lah apa benda yang kita akan belajar nanti. And basic-basic benda lah. Okay. So in DC analysis we need to determine on the voltage and current. Okay, dah dapat that things, the value kita akan carry dekat dalam AC analysis pula. In AC analysis, okay, this is yang tadi tu. For AC analysis, this is symbol untuk BJT kan. In AC analysis, we will not use this BJT symbol. We need to convert into AC equivalent circuit. Okay, AC equivalent circuit kita akan kira Z in, Z out, and also the AV. Sekali. Dekat dalam DC analysis kita cuma cari DC current and voltage, tak cari lagi AV dengan AI. For AC analysis baru kita cari dia punya AV and AI. What is the purpose? Because the transistor kita apply dalam switching and also dalam amplifier kan. Sebab tu penting untuk kita kira benda ni. Kenapa? Because bila kita nak design satu amplifier circuit, mesti nak tahu spec dia. Okay, nampak tak relationship dia? Daripada DC, lepas tu nak pergi ke AC. Purpose dia, if you want to design sesuatu sistem for voltage regulator ke, for amplifier, op-amp. Pernah dengar op-amp? So inilah yang di dalam analisis dia. Okay, sebelum kita come out dengan certain value, so nak input berapa, nak output berapa, this is the analysis yang penting. Okay, yeah. Okay, all good. Take 5. Okay, take 5. Baru sikit ni. Ha? Banyak sangat? Saya laju sangat ke? Okay, kita kena stop dululah. Okay, the first configuration is common base. So, common base, it has high AV, unity AI. Okay, so for that common base, input will be connect to the input is connect to the emitter, output is connect to the collector. So base will be common for both input and output. Okay, dia ada dua, NPN and PNP. I want to show this one rather than kita pakai this circuit. Saya nak tunjuk this one because yang ni lagi nampak. Okay, so this is input. Alamak, mana pula ni? This is the input, this is the output. Okay, beza dia for NPN and PNP is just on this one here. Okay, input and output. And if we have this input signal, this one will be the output signal lah for NPN and PNP. Okay, and dekat sini akan ada V in, here is V out, here is I in and also I out. Okay, so from there kita boleh dapat the AV and also the AI. Okay, for common base, normally common base yang akan goes to the ground. Okay, emitter, collector. This is emitter and this is collector. Okay, balik to our circuit, to our notes. Okay, this one. Okay, this is the hari tu, remember in chapter 2 kita ada tengok on the IV characteristic. Same goes here. This one is also on the IV characteristic, but then this one kita focus on IC and the VCE. IC and VCE. Okay, and for this amplifier, this transistor normally kita guna in amplifier ataupun dalam switching. Okay, this one is we call as the saturation region on condition. Banyak N. On condition. Okay, di mana dia tengah nak naik. Okay, for these positions. And yang bawah ni is the cut off region. Laju dia. Off condition. Okay, and for on condition ni, this one at saturation, what is the value for VCE? Equals to 0 lah, sebab dia lebih kurang dekat axis kan. Cuma yang ni dia lukis dekat negatif, tapi sebenarnya dia start dekat tengah ni kan. So dia 0. How about dekat sini, dekat cut off region, idea equals to Z. Sebab when kita nak on, kita mesti ada value I, kan? Sebab short circuit. This one is open circuit. Kalau yang open circuit, sebab tu I dia tak ada. Okay, during the off condition. Okay, and then yang tengah ni, all this is for operating condition. Yang tengah ni, this all for operating. Active region is for operating. Okay, nampak tak? And this one is IC, this is VCB. Tapi yang tepi ni is the value of IE. Sebab for common base, input dia dekat sini adalah input, this is output. Sebab tu kita ambil the IC. Sebab kita ambil output dia. Okay. And BJT is a current control voltage device. So value I will determine the value of voltage. Okay, nanti bila kita buat on DC analysis, you guys lagi nampak lah. Okay, this graph demonstrate the output IC to an output voltage VCB. VCB dekat mana? Sini kan? Kalau dekat dalam circuit ni, circuit yang ni, VCB dekat sini. Nampak dekat output kan? Sebab tu kita ambil IC, sebab kita nak dekat output. IC dekat belah sini, VCB pun dekat output juga. Okay, sebab tu dia punya IV karakteristik dia tadi, IC versus the VCB. Okay, ini untuk common base. Common base dia ada high apa? High AV, unity, I. Yang ni tadi, this one. Common base, high voltage gain, no current gain. Okay, for common base. Right, this one is for the analysis dia. This one comes from if value for IB is, so we can say that IC is approximate to IE. And this one is comes from ni, kalau nak on, value untuk VCB must be at least 0.7. Sama dengan diode punya karakteristik kan? Okay, and ini adalah amplification factor, relationship between IC and IE. Not to worry too much on this alpha value, sebab agak jarang calculations melibatkan alpha. Normally calculations dia akan bagi beta. Okay, IC equals to beta plus 1 IB. So this beta value dia akan bagi dalam spec of the transistor. Dia bagi value circuit, dia mesti bagi value beta. Contohnya like this one, dia mesti bagi terus beta equals to 100. So kita guna this beta value dalam calculation kita. Okay, and kat mana nak guna the beta? Bila kita nak apply, contohnya macam ni lah, kita dah dapat IB, tapi nak dapatkan IC, gunalah this relationship, kan? And this relationship pun will not be given, you kena ingat yang ni. IC equals to beta plus 1 IB. Okay, biasanya IB yang paling senang nak cari, sebab VBE kita dah tahu 0.7. Okay, contoh this one, common base configurations amplification. Okay, contohnya if we have I in kat sini, IE pun dekat, sebab tu E is at the input, this is V in, so we have the I in. R in is bila kita tengok from here. So how to get the value of I? ataupun IE equals to V over R. So this value V, this value of resistor kan. So we can get the value of IE equals to IE. Okay. So this one. And from the assumptions that IB is too small, so we can say that IC equals to IE. Okay, ni yang paling simple lah. Tapi please not to sentiasa guna value IB equals to 0. Okay. And
So, bila dia nak guna I equal to 0?
IB equals to 0 kalau dia bagi tahu, baru you apply macam tu. Kalau tak bagi tahu, then kena measure, kena calculate lah. Okay. Alright. So this one IL is equals to IC. IL equals to IC. Tetapi from these expressions, kita dah dapat IE tadi kan, dekat input. So equals to IE. Kenapa? Sebab IB equals to 0. Kita assume it is too small. Dia tak lalu pelah sini. Dia straight away apa yang masuk, keluar dekat another one port je. Okay. Sebab tu IL equals to IE, dapatlah this value juga. Okay. And how to determine VL equals to V out? I darab dengan the resistor. Okay, not this one Ini resistor yang dekat dalam ni. Ini resistor dekat load sahaja. Okay, resistor at the load sahaja. So darab dengan 5K, dapatlah 50. Now we have the input and output voltage. So this is the input voltage, this is the output voltage. Okay, so for AV is equals to voltage out over voltage in. Voltage out sama dengan voltage L kan. So dapatlah this 250 voltage gain. Okay, how about the AV? AV dia berapa? AI. AI equals to I in over I out. Kan dia bukan 0, dia 1 kan. Berapa? 10 mili over 10 mili juga kan. Ini maksud dia no current gain. No current gain sebab equals to 1. Value yang masuk sama dengan value yang keluar. Dia bukan 0 No current gain, it is not 0. Okay, boleh this one? Simple je ni. Okay, so next we go to common emitter. Common emitter is normally calculation selalu guna lah. Okay, common emitter. Common emitter we have high AV, high AI juga. And for sure kalau dapat dua-dua high, AP dia pun mesti high juga. Okay, so this is the connections. Emitter, this is input, this is output. Okay, for NPN and also for PNP sama, input and output. So kalau kita tengok on these types of circuit, common emitter, alamak gambar dia pula yang bergerak. Apa ni? Okay, alamak. Sama je macam tadi. Cuma this one input is at, input kat mana? Input dekat base ke, emitter ke, collector? Okay, so input is at base, output will be at C. So what will be the common? Emitter. Okay, so I out, IB, IC, salah, ni I in, I out. Okay, V in dekat sini, V out dekat sana tu. Okay, so that is for common emitter. Kita tengok notes tadi balik. Common emitter, sama je lah macam tadi. This is input, this is for the output. Okay, and common emitter dia ada high gain for voltage and current kan. So this will be the saturation region, this is the cut off region. Okay, output dia dekat IC. C kan. And voltage output dia adalah in between apa tadi? VC VCE. Bagus, dah faham dah kan. Dia ambil dekat output. Okay, VCE. Tak sudah lagi siren tu Okay, if you observe, kalau observe yang tadi dekat operating region dia straight line kan, dia cepat stable. As you compare for this common emitter, dia cepat aktif tapi dia continue to increasing kan. This one, this is value for IB dekat input. Kalau yang tadi IE, sebab input dia IE, this is output. Yang value ni adalah value for input. Apa tu yang ni tadi? This one is IE. Ni. Sebab input dia adalah IE. Yang ini output. Dia plot output dengan output. Voltage, current versus voltage. Tetapi in between plotting dia tu adalah input punya value lah. Nak plot mestilah ada input kan. So yang ini adalah input. Kita nak contohnya satu value. So this is the input. Input dia adalah IE according to the circuit dia. Macam mana nak dapat tu? According to the circuit dia. Okay. Kalau sorry. For this common emitter, input dia adalah base. Sebab tu value dia base. And remember tadi I mention for the base, value dia is very small dalam micro. Kalau emitter value dia mesti dalam milli. Okay. So this is for the active region. Dia punya plotting slightly different daripada tadi, because this one is high voltage gain, high output gain. So amplification factor dia must be very high. Okay. Alright. So yang lain tu tak jauh beza. IE equals to IC plus IB. And this one is kalau kita pakai alpha. Tapi agak jarang lah. Normally kita guna beta. Beta value will be given. Dia nombor genap biasanya 80, 100, 150, depends. Okay, not to worry, the value will be given. Kalau dia tak bagi value beta, dia akan bagi value current, so that you boleh manipulate with the relationship tu. Okay. Alright. Okay. In DC mode, in DC normally kita guna value beta. Beta IC equals to beta IB. From this one kan? From these expressions. Okay. And kalau in AC mode, it is actually the changes of the current. Okay, kalau in beta, in DC, value of the current IC over IB. Tapi for AC, it is the changes. This is yang penting lah. Yang dalam kotak merah is the important one. IC equals to beta IB and IE equals to beta plus 1 IB. Okay, meaning that once kalau dah dapat IB, straight away sepatutnya you boleh dapat the value of IC. Same goes with the IE kan. Okay, just use this relationship lah. Okay, for this one sebenarnya agak jarang ditanya. It just kita pergi sekali lalu je. For the determining beta value of the graph, it is actually datang daripada yang ni. This one, beta and this one. Okay, kita tengok for AC it is the changes. Sebab tu dia ambil 3.2 tolak 2.2. This one tolak yang ni. Sorry. IC kan, current. Yang ni 3 tolaklah 2.2. Over, ambil this value 30 tolak 20 tu. Tapi it's actually this point lah, the 2 point. Okay. So the changes yang segitiga tadi tu, sebab dalam AC, beta AC. Okay. Meanwhile for beta DC, kita ambil I B over I C. Sebab beta IB equals to beta I C kan. Okay, so it just the value 2.7 IB mana 27 lah kan. 2.7 is 2.7. This one lah somewhere kat sini. And over 25 micro. Ini adalah 2.7 adalah, sorry, terbalik lah ni. Sekejap This one. IC over IB kan? IC over IB. So 2.7 is IC, 25 micro is IB. This one is bila kita cut dekat 7.5 ni. So bila kita cut ambil kat sini, tu yang dia tulis macam tu, at VCE equals to 7.5. Okay. So it is ni kat sini ni. Ni, yang ni. Sebab tu dia tulis macam ni, at VCE equals to 7.5. So this is the point yang kita guna dalam this calculation lah. Okay. And kat bawah dia tulis, note that beta AC equals to beta DC. So biasanya the value tak akan lari jauh lah. And then dalam spec dia, when we comes, contohnya bila kita beli satu transistor, dia ada dia punya sheet dia tu, beta value is the bit, dia macam spec tu, kalau kita beli barang dia dah datang sekali kan. So beta tu dia punya one of the spec of the transistor dia lah. So suppose antara 100 dengan 108 ni satu value je yang kita guna. Normally kita pakai nombor genap lah, 100. Okay. Alright. So next one. Okay, yang ini faham macam mana graf dia boleh naik macam ni. Okay, sebab dia it is a very active one. So amplification factor dia sangat besar. Okay, this one is for common collector. Kalau common collector, kat sini common. Okay, this one common collector, input dia apa? Base. Output dia is emitter. And C is the common in between. Okay. So this is V in, ataupun kadang-kadang VS, benda yang sama. This is V out. Okay. Same goes for here in this graph. So this is input. Ni VC common collector. Okay, this is the output. Okay. For PNP ataupun NPN sama je, it just directions of the current yang berbeza. Okay. And input dia is output dia adalah C kan? Alamak. Okay, VCE IC kan, IE equals to IC. Okay. Yang ni kita tak ambil sama je lah antara dua tu. Okay. VCE is maximum, and at this point at saturation, VCE is equals to 0. At cut off, IC ataupun IE is equals to 0. Okay, minimum value. Okay, IC is maximum. This one is maximum at saturation kat sini. Okay. And the transistor is operate in, this one is active region. Dia almost with, dia in between. For common collector, dia in between. Kalau yang the first one tadi, common base kan. Sekejap common base, dia macam naik and then straight away dia stable kan. Dia straight line. Kalau for common emitter, dia increasing kan. For common base, sekejap, mana dah? This one. Ini kan. Okay, dia naik tapi dia tak laju sangat, dan dia stable pun agak-agak je, kat tengah-tengah tu je. Okay. For this one, common collector. Common collector dia apa yang high? High AI. Unity AV. Okay, for common collector. Common emitter both are high. Okay. What else? This is power dissipation, tak ada apa sangat. At common base, P PC is kita ambil the output dia lah. This one pun sama, ini pun sama, at the output. Okay, this is tak ada apa pun on the explanations dia. Nanti saya bagi link yang you guys boleh sambil-sambil nak baca saya dah bagi ke? Belum kan? Sekejap. Okay, this one. Sebab gambar tadi tu saya ambil daripada website ni. Tak sempat nak buat dalam nota sebab baru jumpa. So you guys bolehlah nak baca-baca. Okay. And this is antara value-value yang kita akan kira nantilah dalam DC analysis. IC, IE, IB, VCE, VCB. VCC is the supply voltage, input ataupun output dia lah. Input normally VCC ataupun VBB or VEE. Okay, this is the spec for the transistor. Ini salah satu dia 2N4123 ataupun 2N2222. So when you comes together with this, dia ada dia punya beta value. Mana tetapi for the beta value tu, bila kita nak buat connections, kita tak tengok sangat pun. It's just the thing yang when we want to do the DC analysis, baru kita tengok the beta value. Okay, so this is the spec lah. Yang penting adalah for this thing, kena tahu dia punya kaki dia, which one is emitter, collector and base. Dia tak tulis kat sini biasanya. Kalau tengok dia punya gambar dia, tak ada tulis pun. Ni je lah. Okay, and sekarang ni nowadays the transistor ni become lagi kecil. Bila lagi kecil lagi susah nak determine dia punya pin dia. Apa dia? X-ray. Dia tak ada X-ray, dia ada alat untuk baca kaki dia. Dia alat dia tu macam multimeter untuk determine pin dia. Macam kalau kita set letakkan scope macam oscilloscope punya. You guys, oscilloscope biasa guna kat mana? Dalam lab. Yang dia ada clip wire hujung dia tu. Ataupun multimeter lah, yang hujung dia ada dua hitam merah tu. That one kita letak dekat kaki dia ni. So dia akan baca lah. Dia ada alat yang boleh baca. Tapi from the alat tu sometimes kita kena tahu jugalah daripada nak baca kod depan ke kod belakang. So ini adalah contoh-contoh je lah. And nak bagi tahunya this thing is very small sebenarnya, the transistor ni. Okay, alright, so kita dah habis dah on the notes. Yang ni nantilah kita buat. Dah habis-habis chapter nanti. Habis chapter lah. Okay, tapi sekarang ni jawablah yang quizzes tu dulu. Okay, ada soalan tak?
Pandai-pandai je.
Remember, dalam test dia mesti ada common base atau common collector atau common emitter. Antara tu lah, dia mesti ada.